Welcome to solverfy.
So we're told that two L 76 by 76 by 6.4 millimeter angles are welded to a C 250 by 22.8 channel. And we want to determine the area moments of the combined section with respect to the centroidal axis, respectively parallel and perpendicular to the web of the channel. Okay, so these are our axes, and our centroid is going to be somewhere on here. We'll have to figure that out. But we can look up the properties for our different sections that we've welded together. And so for the area for the C channel is this, and for the L brackets is this. And so the distance here is 254 millimeters. So that's the distance between the outer flanges of the two C channel, and then also the distance here because these are lined up. Now, we know that X bar is going to be 0 because the axes I've defined here. Okay, so I've defined these axes at the top of the C channel web, and we'll figure out where the area moment is with respect to that. But we know, and I've defined the y-axis as just at the center of this, and so we know because of the symmetry that X bar is going to be 0, and Y bar we can figure out. Okay, so we have we just got to remember that we have two of these guys, so we need twice this, and we can look up this and we can look up this, and so when we do that we find that Y1 bar is 16.1 millimeters, but it's in the negative, it's down here, so it's a negative. And then this is 21.2 millimeters up from this part of the L bracket, so up here. And then this one is also up here. We plug in all of those numbers and we get that the centroidal Y coordinate is minus 1.5 millimeters, so down here somewhere. Now we can look up our section centroidal properties. We'll look those up in the book. So for the C channel we have these area moments about its centroid, and for the L brackets we have these area moments about its centroid. So then we need to use the parallel axis theorem to shift things. So we find the area moment about the whole section centroidal axis is this area moment for the C channel is the area moment about the C channel centroid times the area of the C channel times the distance from the centroid of the whole body to the centroid of the C channel squared, and we get 1.56 times 10 to the 6th millimeters to the 4th. Do the same thing for the L shapes, and we get, or the L angles, and we get that those give us 0.991 times 10 to the 6th millimeters to the 4th. Okay, so we have all these values, and we know we can get the total area moment about the centroidal axis by adding these things up and remembering that we have two of these. So we get 3.54 times 10 to the 6 millimeters to the 4th. Again, we can do everything the same for Y. Okay. But we have to be a little careful because we need to use the parallel axis theorem to get the area moment about the centroidal y-axis, because the centroidal y or x coordinate of these L's is not on this axis, although this one is. So IY2 is the area moment of the y about the y-axis, about the L bracket, the L angles, centroidal y-axis. So then we have the area of the L angle, and d over 2. Okay, so the distance here, that's the distance it shifted to this point. But then we know that the centroid in the x direction is also this value, so we have to come back, and so that's the distance from here to here, is this value here. And we know all this, so we can plug in and we get 11.4 times 10 to the 6 millimeters to the fourth. And now we know that the area moment of the C channel about the centroidal y-axis is the same as the area moment about the C channel's centroidal y-axis. So we have that, and so then we can plug in, and actually this should not be a bar on top of here. And so we plug in and we get that the area moment about the centroidal y-axis is 49.8 times 10 to the 6 millimeters to the fourth.